Water quality sensor. Today I will be talking about how I made a compact, affordable, and effective water quality monitor using Arduino circuit boards. I will also go over some other alternatives to monitoring the quality of water and many other things in this presentation. So my question for this project was, what is the most affordable but effective way to find the quality of water? So here comes the purpose of my experiment. The purpose of this project is to provide an affordable, robust, and simple water quality detector for areas where clean water is difficult to find. Every 10 seconds, a person dies due to drinking dirty water. That's 3 million people per year, 2/3 of which are children. Clean drinking water that is readily available is a luxury that many people don't have. This is the fundamental reason for making this device. Dissolved solids are impossible for the naked eye to see, but my device helps solve that. So about 3 million people die every year due to dirty or contaminated water, 2.2 million of which are kids, and every 10 seconds someone dies. After going through many different design ideas, I settled on making an Arduino-based water quality monitor / sensor. So here are the materials needed to build my sensor. One Arduino / Genuino Uno board that is compatible with a dissolved solids meter, and you might require 3 jumper wires to connect the sensor with the Arduino, a connection to a computer, and the Arduino programming IDE. So the procedure to build the Arduino water monitor is attaching the VCC, or the positive wire from the dissolved solids meter, to the 5-volt port on the Arduino. And then you attach the ground wire, or negative wire, from the TDS meter to the ground port on the Arduino. You then attach the analog out wire from the TDS meter to the A1 port on Arduino. It doesn't have to be the A1 port, whichever analog port you have available, you can plug it into that one. And then plug your Arduino into your computer using a cable. And then in the Arduino code IDE, use the following code. And what this code does is basically setting up our sensor, setting up a temperature for the water, and it will interface with the TDS sensor and give us the readings in the console. So to view that console, just open Tools and Serial Monitor. So here is a look at the console or serial monitor for the Arduino IDE. And so now I'm going to quickly go over how it works. This device works by having the dissolved solids meter, or the TDS meter, connected to the Arduino that puts the parts per million into a computer. The dissolved solids work by measuring the amount of particles bouncing between its 2 metallic tips. More bounces between the metallic pins means more parts per million. The bouncing between pins is affected by temperature and the amount of particles. Since higher temperatures means the particles move at faster speeds and there's more bouncing between particles. And the more particles there are, the more bouncing there is. The device automatically negates the temperature difference, and so this way we get the most accurate reading from the TDS monitor. So for testing my experiment, I used 3 cups of water, each with different amounts of salt, to make sure my sensor worked. 1 cup had no water, which is my control, and the average ppm calculated over a minute was 147.13. The second cup, with half a teaspoon of salt, had 11,058.85 parts per million. The final cup, with 1 teaspoon, had 1,277.56 parts per million on average. The mode parts per million was 148 for the first cup, 1,179 for the second cup, and 1,279 for the third cup. And one thing to note is that all water was at an approximate temperature of 25 degrees Celsius. So here is a picture of me pouring the salt into the 2 cups and pouring the water into the cups. And now we move on to the evaluation. So the point of this experiment was not to see how effective the device was, but instead have a simple device that can detect the water quality of large volumes of water in third world countries. Instead, this will stand as an evaluation of the design and changes that would make this better and more effective. Changes to this design include adding an LCD display to read the parts per million without plugging it into a computer, because that is very inefficient. Another change would be to add a website to send the data to. This way, all the data can be graphed along with the place it was recorded at. A Wi-Fi module connected to the Arduino should make this possible. The data would be sent to an API, which the website fetches the data from. Then you can see the data all clearly. The pitfall to this design is the cost. The price of a Wi-Fi module and an LCD is an awful lot, $7 and $5 for the Wi-Fi and LCD. But on a larger scale, this could potentially be quite expensive. Though an LCD is a must. Carrying a computer around to measure the ppm is very ineffective, and cost is not friendly to the costs. So now I will quickly go over the alternatives to my design. So my device is one of the many answers to my question. Other forms of water quality measurements include paper strips, which have a certain chemical coating. These chemicals change colors depending on the amount of dissolved solids and turbidity inside the water. But I realized that this would be the best design since I didn't find anything out in the market that was similar to mine. So, conclusion. In conclusion, this device does its job, but there are many improvements that can be done. Contaminated water is a huge problem across the world, and I hope to make this device into a proper reality. Thank you for listening.